So sharing my screen. Can you see my screen? So yesterday I was talking about this program, sir. I think let me open this. Okay, we are discussing about anyone is typing anything? So now let's continue. So what we do is we'll try to implement a few more programs and then jump to a few more scenarios. Okay, I'll try to come up with as many use cases as possible, as many this thing as possible. But these are all the very core important logics which is useful in any way because this makes you hands on with all this for loop, while loop, and combination of using for with the decision making statements, all that stuff. Okay, I think we build this printing factor, sum of factors, count of factors we have discussed till this. We need to do two more programs in this list. One is perfect number, the other one is primer composite. Let's implement these programs now. So run new and then Python file. So let's do perfect program first. Perfect number. Okay, check our demo or test or anything is fine. This is the program. So in this, what we do, we had already a detailed discussion in our yesterday's session about how to create a count sum of factors. What is that? So to do perfect number is simple. So what is it? If sum of factors of a number is equal to actual number, including factor of itself. So sum of a perfect number is what? Simple. Sum of factors of a number equal to actual number. Okay. Then it is perfect number. For example, you can take a small example here. You take 6. Likewise, there are so many perfect numbers. You can try to get all that perfect numbers. If you have 6, you know, right, factors of 6, 1, 2, 3, and 6. Now what you can do, 1 plus 2 plus 3 plus 6. Okay. So what is it? Sorry, excluding factor of itself. There is a small correction. If sum of factors of a number is equal to actual number, we should excluding factor of itself. This is called perfect number. If you add factor of itself, then never ever we can see a perfect number. If you want to check if a number is perfect or not, we should exclude that factor of that number. We should not add that factor into the sum. Okay, we should not add factor to the sum. We should exclude factor of itself. Don't add 6. See, now add this other factors other than 6. 1 plus 2 plus 3 is 6. Then this is a perfect number, right? So if sum of factors of a number excluding factor of itself is equal to that number, then that is a perfect number. Okay. Now let us build this logic. Are you ready to build this logic? Now what do you do? So first you input n from keyboard. You know what to do here. So do a conversion to integer. Input of, what is that? Enter n. Just read a value come from keyboard. Okay. That is one thing. Next, after that, what you have to do? So to find sum, you can take a variable result and then assign to 0, right? And after that, iterate loop from 1 to n. This is what you should do. What is that you should do? iterate loop from 1 to n here. Now here you take a for loop for I in range of, right, 1 range of, okay, 1 comma n plus 1. You can do one thing. You can iterate till n plus 1. Of course, here you can just pass n. Let me explain why we should pass n instead of n plus 1. Because we don't want to add this factor to that result or to that sum, total sum. So we are excluding adding that factor of itself to the sum of factors. So that's why if you directly pass n, it will iterate till n minus 1, so that whatever is n, suppose if n is 6, that 6 is excluded. That is not added to the result. Just a minute, friends. So okay, sorry friends. So there is some noise coming from outside. So this you just need to exclude n. So just pass n directly so that this is excluded from this iteration. Now after that, if right, you should see if number is a factor or not, that I is a factor or not. N percentile I equal to 0, because we have already discussed this number of times. I am going little fast here. Okay, the result equal to result plus I here. Okay, this is what we should do. And this perfectly gives you sum of factors excluding factor of itself. Okay, so here we are reading n, that is fine. And then we declared a resultant variable, set it to 0. And we are doing a condition check here. Okay, so this condition check is what? To see if this I is a factor of n or not. So if it is a factor, we try to add that factor to the result. Okay. Finally, we are done with this, and finally checking what is that, perfect or not here. Once that is done, come out here, come here, outside that for loop. Don't do this condition check inside for loop. Come out of that for loop, and then here you have to perform this condition check here. What is this condition check here? Simple. If this result, whatever you have here, equal to n. What is that? If your result, whatever that sum you have done here, whatever that total sum you got with excluding factor, you should exclude factor here. Okay, then that you have to check with the you mean compare with n. If these both are same, if the total sum and this n is same, then it is a perfect number. Print. Okay, what is that in double quotes? Let me just add. The number is perfect. Okay, maybe if you want, you can print that number, whatever that is. Apply format. So what is that number? You can just pass that n. Okay, that you can pass n. Maybe in place of number, you do one thing. Put a placeholder here instead of here. Okay, now you can directly see that this so and so number is perfect. Okay, final. Else what? Suppose not every time a number is perfect, right? Then you can simply say copy this, paste it here, and then the number is not a perfect number. Okay, you can simply say not a perfect number. That's it. Here also, you can simply say this is perfect. So this is how we can build this program, friends. You got it right? This is how we create a program to check whether a number is perfect number or not. So this is reading inputs. declaring resultant variables and setting to some initial value. And this is the core logic where that sum of factors is done here. And then this is the validation. So this is validation part. If that result and that n is same or not, if they are same, we are validating if it is perfect or not. So we have just three different parts in this code. I hope this should be clear for all of you. Now run this, give a number 6. You can say 6 is perfect. Again run it, give a number, again test it. 10. 10 is not a perfect number, you can see here. So you can say, you can remove the is not making much sense to the statement. Okay. So now this is fine. Again, give some 12. 12 is not a perfect number. Maybe you can just quickly check in this one. What is that? So let me open Google. Okay. And then just do quick Googling. Or you can use Chat GPT for your questions these days. Okay. Stuff. Google. Okay. So you can ask our dear Chat GPT. What is that? Hi, dear Chat GPT. Okay. Can you please print me? You don't need this respect for Chat GPT. I'm just only okay. Can you please print me perfect numbers? Okay. I'm just showing you how to use Chat GPT as well. Most of you know this. So this guy also gave me this 6 only, yeah. Okay, along with program. I don't need this, buddy. Print all perfect numbers, buddy. Okay. Print all perfect numbers, not program. We have to clearly give prompting for ChatGPT. So you can see 628, 496, 8128. These are perfect numbers. Okay. So then let us test one more quickly because ChatGPT gave us this for few perfect numbers. So what we do, let us use 28 if it is a perfect number or not. Actually, ChatGPT also gives you the program. And if you are just depending on ChatGPT, then again, it's very difficult to manage in your career. Okay. So just take this kind of help, but don't depend here unless and until you are an expert in or an SME in that area. Then okay, when you are an SME and expert, then you can provide prompts to ChatGPT and get this code and you can insert it to your project, all that. But again, not violating the policies. Okay, for us anyhow, we don't have any that opportunity. We cannot use it. Now right click, retest it, pass 28 and see if this works. Okay, I want to test 1828 because it has so many factors. Okay, how much time does it takes? I would like to see. Does it quickly does that or it takes more time to perfect? See, just fraction of seconds, it's just giving the output. So see how great this is. Understood now? So means we are actually this program is working really well. We are good with that. Okay. So now I'm sharing my this thing code. Just you can take it and test it if you want. If you already tested, please confirm in the chat box. Please confirm in the chat box. Is it clear about perfect number? Now prime or composite. Can I get an S from all of you? Or all of you are able to test this code? Maybe my suggestion is try to execute code along with me. Okay, that's what my good suggestion to all of you. Okay, practice it with me. Any doubts you can also ask me, no problem. Now, another program. This is perfect. We are done. Another is primer composite. We already had a strong foundation in yesterday's session. So what we do today, we again continue on top of that foundation we had yesterday. So I believe we created a program primer. No, let's create prime or composite check. This is the program, right? In future, once you get done with functions or methods, once we cover for functions topic, all this code has to go into functions. We should not directly write like this. So maybe when you get into any development, we don't just write statements in freestyle like this. This is freestyle coding, but this is not a modularized approach of doing coding. So when you are doing when you are working in some project, what is that you should do? You have to create program in such a way that it is properly modularized. So all this code has to go into functions. This whatever logic this is there, this is something which has to go into a function. You got it right? So that's how you have to build your code. But for now, you practice this. Maybe once we discuss, cover this functions topic, then we will again revisit these things and we will see how to rewrite these logics with functions with a better modularization. You got it right? So finally, we are getting into this topic. What is it? This is the example is what prime or composite. Okay, creating a quick metadata and who is the author here. For this program, I am the author, but this logic is there from many decades or from hundreds of years. Okay, so prime or composite. Okay, fine. Now, I'm sorry, author is Manoram, right? You can put your name there. Here, this is my program. I put it as Manoram. Now, if you want, you can add date as well. That makes more sense. Right, next one. As usual, what is that you should do here to to find prime or composite? The important thing you should do is you have to find a count of. So the logic part is what is the logic part? Count of factors of a number. First, this is what you should do. This is step one. Once you found, validate. This is step one. And next one, maybe you can take it as a quick algorithm. Okay. Step one. Step two, what is step two? Once you find count of factors, validate count. Okay. Validate if count equals to 2. Then if count equal to 2, then it is prime. Else composite. Okay. Else composite. This is the actual quick algorithm, simple algorithm. So what is that? Now you have to create this program. Simply, what is that you do now? As usual, same routine story. Read n from keyboard. That is one thing. Okay, how do you read it n equal to? You have to do casting that is numeric string to integer. Apply casting and then input of what is that you should do? Take input method and then just pass enter n here. This is optional. This string is optional. If you want, you can pass it. Else, you even this input functions without this function. This input function works even without this string. This is just only for our visibility and readability. Because when you run it at the prompt, it gives some things. It gives some statement saying enter n. Even if you don't pass it, nothing happens. But you should know that once you run, you should pass that value. Okay, that is the idea. Just giving you a quick tip. Might be you might think every time we should pass enter and that is mandatory. This is not mandatory, this string. This is optional one. Even if you don't pass this string, this input function is ready to read a value from keyboard. Only thing is when you run, you get a blank here, just you need to input that a value directly. If you add this print this string statement, it makes more sense. It has enter in so that we can pass it. Okay. This increases readability to your code. Okay. Fine. Next one, we have read n. Then again, for this also, we have to take one variable here. You can directly choose count here. What is that? Huh? Count here. Just a minute, friends. I'm getting some. Just a minute, friends. I'm just getting a call. Sorry. Sorry for the interruption, friends. Okay. So let's continue. So where are we? We are trying to understand this. Okay. This is a quick, you can write it as algorithm. So this is how you have to create a program and include code hygienic to your this thing. So I've still, okay, this is one. Next, we declare count here. First thing, what is the important thing? The first step is find the count of factors. What is that you should do? You should iterate this loop from 1 to n. So the point is iterate loop 1 to n. This is one thing. Next one, for that use for loop for I in range of 1 comma. This time you have to do till n plus 1, no concession like in the previous example. Okay, we have to iterate it completely, friends. So we have to iterate 1 through n and see that how many factors are there and see and get the count of all factors. So don't exclude factor of itself here. Even we have to include factor of itself. So put n plus 1 here. I have clearly explained yesterday why we should put n plus 1 here. Okay. So now after that, you have to do a condition check. What is that condition check? If that I is a factor of n or not. So condition check. What is that? If n percentile I equal to 0, this is what we should apply. And then we should say count equal to count plus 1. Okay. So this is step state. We have to do this count incrementation every time if n is a factor. Don't add any I to this, just increment count. When I is a factor, every time if I is a factor, just try to increment count. That is enough, friends. Don't do anything else. Don't add I or anything to this count. We get just count of that factors. How many sorry, friends. How many factors are there? This is discussed yesterday. Again, I am rediscussing about this topic. Finally, we are done with step 1, which is the core logic. We got the count here. Next one is step 2. What is step 2? Validating count. To see validating count, to check if number is prime or composite. Okay. So this is another important thing. Now, if what is that you should do if count equal to 2, what is that? Just to do a condition check. Already we have count here. Simple thing is we are learning this prime thing since our school days. Okay, prime number means it has only 2 factors. We know that. Then just simply say if count equal to 2, just print it. So that number, print that number, whatever number it is, use a flower bracer is prime number. Okay, and then you apply format here and to this pass that n here. That then this n get substituted in this placeholder. Okay, is that clear now? Now else colon, copy this again. You can same statement, just same print, just make a small change here. Instead of prime, just change this to composite. So if count is 2, then we just try to print. We just confirm that number is prime number. If it is more, if it is not 2, if count is anything else other than 2, then it is a composite number. Okay, right. Now this is a simple approach to check whether a number is prime or composite. I hope this is clear for all of you friends. Okay, right click on this and then run. Enter n. All of you know from school days what are prime numbers: 2, 3, 5, 7, all that stuff. I give 7. 7 is prime number. This programming is working perfectly. Suppose I give biggest prime like I don't know biggest prime. Let me give ask Google this GPT. Okay. Okay. Print me first 50 primes. I'll just take first 50 primes. Okay, seems like these are all simple ones. Just pass 229, which is a prime number, and test it. 229 is a prime, but we have to test the other way also. See if we get a composite as well. Test for composite as well. So now pass some 10. Definitely 10 is a composite number because it has more than 2 factors. So see if you are getting proper output for this. Yes, 10 is composite number. Our testing is properly successful. It's properly fine. So what is that? We are good with this prime or composite stuff. Okay, what do you do right now? I'm just sharing in the chat box. You can, what you can do, you can take this code and then you can test it if you want. Okay, and just please confirm if you have tested it. Anywhere, if you have any doubts, you can ask me. I'll try to explain in detail. If it is done, just please confirm in the chat box, friends. Okay. Just please confirm in the chat box, or a thumbs up also works. Raising hand or thumbs up, anything should be fine. Okay. You have some special this thing here. Okay. So this is the idea, friend, how to implement prime or composite. It is a simple program. We have seen all steps in that algorithm, and we have tested that code as well by providing multiple inputs, both prime numbers as well as composite numbers, and we tested this code. Okay, this is the simple idea about prime or composite. So I think we try to cover most of this core logics of any programming language. These are very, very core and very fundamental, very useful as well, because this logics gives you a what is that we should say? It helps you to become hands-on with your all that basics, that loops, that decision making statements, all that stuff. Okay. Now, palindrome Armstrong. So how to do this palindrome or Armstrong with for loop? We can quickly test it. I'll do one thing. Right? Palindrome. We can just add here. What is the logic in directly here? So again, I'm creating a new file, closing this one. Go to this package for loop because we are working on for iterator. So right click, new Python file, just create a program, palindrome test. So what is that you do? Palindrome underscore test. The idea is becoming familiar, becoming good with all the basics. That's all, friends. That is why we implementing all these logics. So this is the logic for palindrome. So we are doing a palindrome program. Palindrome means if you reverse a number, we get the same number, 121. Reverse it, you get 121 only. Similarly, 253. Sorry, 252. If you reverse it, you get same number. Okay. Likewise, if you reverse a number and if you get the same number, it is a palindrome. Got it right, friends? So for this, what is that you should do? So here you can provide the author name. So I am Manoram, just passing Manoram here. And then now, what is the step one you should do? Here, the way we iterate loop will be slightly different here. Okay. So what is that? If you take a number, okay, let's say 121, or you take any number, because if it is not palindrome, we get not palindrome. Take a number n, and what you should do here? While iterating, you should take this number. You should just extract 3 and then do some reversing to that. Again, extract 2, do some reversing to that. Extract 1, do some reversing that. Because if you reverse a number, you should get the same number. So for that, what is that you should do? You take a 2-digit number, 3-digit number, whatever it is fine. So the logic is every time this loop should iterate here. If number is n, then that loop should iterate for n times. Remember, this is the important point. If number is n, what is that you should do? Loop should iterate n times. Means if it is a 3-digit number, okay, n. So how many times loop should iterate? If number is a 3-digit, if it's not n, if number not n. If I say n means n times means it should iterate 123 times. That is not that. If number is n, see number of digits in n. Number of digits in n. Okay. Suppose if it is a 3-digit number, if your n is 3-digit number, okay, then your loop should iterate 3 times. How many times your loop should iterate? 3 times. If your n is, suppose if n is a 4-digit number, okay, then loop should iterate for 4 times. Okay, why? If it is 4-digit, every time loop iterates, we should extract this last digit from that number. Suppose In the first iteration, you have 123. From 123, you extract 3. And for next iteration, 12 will be the input. See here, I'm just giving you a quick idea about the logic here. Okay, similarly, in the next iteration, n becomes, in the first iteration, n is n, 123, right? And from that 123, you try to extract 3. And after that, the rest of the remaining part of this number, you should pass as input to next iteration. So this 12, we have to pass it as input to next iteration. Okay, so that is fine. Then n is 12 now. This time again, loop iterates one more time. You should extract 3. Then what is the input for next iteration? 1 will be the input for next iteration. And after that, again, n becomes 1. Now loop iterates one more time. So then extract this 1 itself directly. Now finally get that 1. And now your n becomes 0. Right? So you should iterate loop starting with that number until that n becomes 0. Till what? Till n becomes 0, you have to keep on iterating loop. So how many times loop iterates? It depends on number of digits in that number. If that number has 3 digits, this loop iterates for 3 times. If this number has 4 digits, this loop iterates for 4 times. First we extract 4, then 123 is passed as input to next iteration. Then from that 123 you extract 3, then 12 is passed as input for next iteration. Like that it goes, friends. But for now, just stick to 3-digit number, because if you clearly understand how to work with a 3-digit number, it is same for 4-digit, 5-digit, 6-digit, or any digit number. But this is the logic about how to work with palindrome. Now, let's get into the programming part now. I have explained about the logic thing and how to extract digits and how to pass the rest of the digit as input to next iteration. And to get all this, what is that we should do in coding? Simple. For this, to extract last digit from any of these numbers, what is that you should do? Divide with 10. Simple solution is simple tip. What is the tip for this? Tip of the day, you can take it as tip of the program. I'll just write like this. The simple tip is divide number by what? Number by 10. Right? Then automatically, and divide by 10 for reminder. Apply reminders in this thing here, operator. Okay. Divide number by 10. So, and get reminder. What is that you should do? You should get reminder. This is what you should do. And again, for quotient also, you should divide by 10. So here, this when you divide by 10 and try to get reminder, then you get 3. And you divide by 10, try to get quotient, you get 12. I'll just show you here, see, in a simple and easy approach. But this is the idea. Tip is to extract that digit from number from digit, or sorry, digit from number, divide by 10. Okay. To get this reminder, apply percentile. To get this quotient, apply double slash. That's it. That would be enough. In both cases, you should perform division with 10. In one case, to extract remainder, apply remainder operation. In second case, to extract quotient, apply quotient operator. I had clearly discussed about operators. Now get into the coding. First thing, read n from keyboard. So reading n from step 1 from keyboard. So how do you read it? N equal to, do the conversion that number to integer, because you know if you read something from keyboard, what is that? By default it is a numeric string, and that numeric string you have to convert it to integer. Okay. Now after that you should start coding now. So how do you do this now? For I in, what is that I should do? I in n. So this time range, can we use range? Range doesn't work here. You know why? Because range starts with some number and then it will again what happens? It has a start point and end point. So I'm just thinking if we can use for here or while is the best option here. So
You can have the count.
what is that, Krishna?
Length of the number first.
Length is fine, but we need directly. We don't need length here, Krishna. Okay, I'll check on that. Let me show you with while here how to build this with while. While you can while is the best choice here, but I'll also explore this with for today and then come back to you in tomorrow's session. Not a problem. So you do one thing. Iterate this n. I'm using while in this case. Iterate this n until n becomes 0 means this is the condition you can apply, n greater than 0. So this loop iterates until n becomes 0. Okay. So that is what happens here. This should be the condition. Once you input this, next after that, get a reminder. To get reminder, you should divide that n with 10. You can see and apply this reminder operator here to get reminder. N percentile 10. This returns reminder. Then you should do a reversing here because once you have a number, you should reverse that number. To do that reversing, you have to take a reverse variable and set it to 0. Now after that, apply the logic here, reverse equal to, so the logic to reverse that number is, this is one. It's almost doing some logic, but only thing is reverse equal to, you can just directly apply the same, reverse into 10 plus R. This is the reverse logic you should apply. You should take this reminder, add it to the reverse. But before that, what is that you should do? You have to multiply that reverse with 10. Because you are dividing with 10, if you should reverse, you have to multiply that number with 10. So that's why we are doing here. But initially that reverse is 0. For first time it will be 0 plus R. 0 plus R means it will be 3 if it is 123. Example we are taking here as 123. You can take whatever you want little later. So in the first case, it try to extract 3 and then add that 3 to this reverse into 10. By in the first phase or first iteration, this reverse into 10 it would be 0. Why it is 0? Because we set reverse to 0. 0 into 10 is 0. 0 plus 3 is what is that? 3. And that 3 is assigned to reverse. And this process continues. Again, in the next iteration, 3 into 10 plus the next element 2, 32. Again, in the third iteration, that 32 into 10 plus that 1, 320 plus 1, 321. You see that automatically got reversed. Got it right? And this happens still when this iteration happens until n becomes 0. So next here, to provide a step statement. See, once we extract reminder and do this reversing, we should provide input for next iteration. Initially, n is 123, and after that, n becomes 12, and after that, n becomes 1. So, to provide that step statement, we should say we should divide n with 10. You can see for quotient, you have to apply here a quotient operator. And this quotient every time we get here is provided as input for next iteration. Okay, this is a simple logic to reverse a number, right? Once you know how to reverse, this is the core part of logic. Once you do this testing palindrome, once you do this, once you implement this logic, okay, this then checking whether this number is palindrome or not is just a simple validation. That's all. The first thing you should do here is, this is the core part of logic, reversing a number. Once you do that, rest of the stuff is very simple. There is nothing in the other part. Okay. So this is the idea. I hope you understood this. So here in the first phase, try to divide n with 10 and get the remainder. In the last phase, try use this, divide this n with 10 and get quotient. That quotient acts as input for next iteration. Every time you get reminder, try to do this operation. Add that to this reverse, which is multiplied with 10. Okay, finally, the number gets reversed here. After this, what is that you should do? Once you do this reversing, you have to validate if it is a palindrome or not. One thing you should remember from all this discussion, by the end of iteration, n becomes 0. Do you agree? By the end of iteration, n becomes 0. So to make sure that we are comparing with proper actual value, you do one thing, take a temp variable here and assign that n, the actual value to temp. So that even if the value of n changes, still the original value is stored into this temp. You got it right? So this is what happens here, friends. So finally, validating. What is that we are doing? Palindrome. So validating palindrome. Right. So how do you do that if that reverse? So what is that you should use? Reverse equal to, don't compare with n. This is actually the beginner mistake we do when you start doing some programming. Even I did the same mistake some 15 years or 20 years back when I just started programming. I always used to compare with n. I get always output as not palindrome. Even that number is palindrome. Why? If you compare with n, by the time you reach here, that n is 0. It's always 0 because after complete iteration, after doing all these iterations, n will be 0. Then you are comparing always with 0. Your number is always not a palindrome. So compare this with the temp because that is the original value, actual value. Then you print, what is that? The number is, otherwise you can directly say in flower braces is palindrome. In that flower bracer, just try to input what format of, which one you should pass here. You can pass this temp here. This is original value or actual value. Okay, just print temp. So then it will just says that temp, that number is palindrome or not. Okay. After that, else, if this condition is not valid, if this is false, then we go to the else part. Then your number is a not palindrome. So copy this print statement. Okay, paste it here and then just change it. If you are coming to else part means number is not a palindrome. Okay, this is the this part, this step 2. This is step 2, validating if your number is a palindrome or not. What did we do in the first part? Step 1, we took number, we try to reverse it. Then in step 2, we are comparing that reversed number to with the actual number. If both are same, then it is a palindrome. If both are not same, it is not palindrome. Let's test it. Let's try to enter something from keyboard. 123, sorry, not there, here. 123, by looking at this value, you can tell it this is not a palindrome, right? Because 123 is not palindrome. Again, run it, test it one more time. This time pass 1 to 1. By looking at value, we don't need to do any program to say if this is palindrome or not. So you reverse 121, you get 121. Then it is palindrome. See there. Got it right? 121 is palindrome. Similarly, if these two tests are, if these two tests are passed, then this program works for any number to check any palindrome number, right? So that is how you have to create a program to test whether a number is palindrome or not. I did this with while loop. What I do is I'll also test it with for, because I don't want to waste time in the session building that logic with for here. I'll do it today and tomorrow I'll share that logic with you with working with for. Okay. So now what is that I want? Let me bring you this program. You can just test it yourself or you can keep it as a backup. You can try it yourself later and maybe use this program as a reference. Okay. I hope you are good with all this, right, friends? This is idea about testing if a number is palindrome or not. All of you are good? Can I get NS from all of you in the chat box? Is this clear? If not, just let me know. I am there to again repeat or recap or make sure that you understand every step in the code. Okay, so do one thing, quickly debug this code, because debugging is something which is really very, very important in a real development. Put a debugger with while so that you understand the execution flow step by step clearly. And each iteration, what is happening, how the values are getting changed, all that you can observe with this debugging. Put a breakpoint here at this line 22, right in front of this file. Now right click and then say debug this. You need to master all these, friends. Just trust me. If you want to become a good developer, whatever technology it might be, right? Understanding debugging, right? Understanding how to that building that thought process, all this is important. So now give some 1, 2, 3. I'm giving 1, 2, 3. We know by looking at that, we can confirm that is not a palindrome. If you reverse 123, you get 321. It is not a palindrome. That is for sure. But let us test it. Now I input 123 here and press enter. You can see debugging started. And here you can see once debugging started, by the time it starts, your PyCharm is showing all that values in that variables here. Inside n it is showing 123. Even inside temp it is showing 123. Inside reverse it is showing 0. Now let us test it step by step here, iteration by iteration. Now you can see here, you can use step over to iterate this step by step. Okay, to go step by step, use this option for debugging step over. And this what this does, this will execute program step by step. So this one, step over, then it has gone to R. Then what happens? You can see here now R is set with 3. It extracted 3 from that N. Now again, next test, go to the next step. Click on this option here. Then it performed reverse. Reverse is updated with 3 here. You can see here. Again, what is that? N. Now again, one more step. By this time, the value of n got modified here. You can see here. Earlier, n is 123. Now n is replaced with 12. Why? You are doing a quotient operation here. This quotient operation replaces 123 with the 12 here. Okay. So that's what happened here. Now again, go to the next iteration and observe step by step process execution flow of that next iteration. So what you can do, again use this option and execute step by step. Now we are checking condition 12 greater than 0 is true, and then we come to the R. This time it will, when you do this division, it try to extract 2 from 12, and you can see there R is assigned with 2. And when you do the reverse, that again 3 into 10 plus 2, this 2 is added to that 3 into 10, 30 plus 2 is 32. And now you can see that reverse is updated with 32 here. And then again you do a division right here for quotient. This time if you divide 12 with 10, what is the quotient? Your quotient will be 1. So you can see now that n got replaced with this is reassigned with 1 here. Now again what happens? This story continues. It moves to the next iteration, third iteration. Now you see again 1 greater than 0 is true. Now what happens? Again we divide 1 with 10. If you divide 1 with 10, what happens? Remainder becomes 0. So here you can, sorry, that remainder is 1. Sorry, I told 0, not remainder. Quotient becomes 0. Okay, if we divide 1 by 10. So remainder, you get that 1 as is. So that R has 1. Now what is that? R already has, this reverse already has 32. 32 into 10, 320, plus this R is 1, 321. When you look at that this final iteration, the reverse is already having reversed number, which is 321 here. So execute that step. And when that step 24 is executed in the last iteration, you can see reverse is updated with 321. And again, you can debug one more time. So what is that? Last one. Now you are dividing 1 with 10 for quotient, then it returns 0. You can see here, if you divide, you can see n is assigned to 0. Finally, we are done with this execution flow and we try to understand this flow, each step. Okay, what's happening at each step in this program execution by debugging. Finally, what? Again, it comes here, checks for condition, 0 greater than 0 is false. Then what happens? Control comes out of this block, this loop. And now does the validation. What is that validation? If this reverse is equal to if this temp. That's what it checks. If both are same, palindrome. But we know this is not same. Why? Reverse is different, temp is different. So it has jumped to else block and we get the output 123 is not palindrome. Suppose you try to enter 121, then it gives you that is palindrome. We tested all that. Only thing is I tried to show you how to debug your program and how to trace each step in that program in that debugging process. Got it? So this is the idea, friends, how to debug a program in Python, in PyCharm. Got it? So today, what did we do? We try to understand, implement this prime composite, perfect number, and palindrome. Armstrong is almost same as palindrome with a small change. For Armstrong, you don't need to do reverse into 10, but just same logic, don't apply into 10. Just say reverse plus 10, that's all. That is Armstrong logic. What is Armstrong means? It depends on number of digits. We'll talk about it in tomorrow's session and close this, all this important fundamental logics and then jump to the next topic. Okay, we'll start data structures probably. We'll start with strings first. So that gives you a very detailed understanding and then we can apply a lot of programs on strings, playing around strings using all these fundamentals, again, these loops, this decision making statements, all that stuff. Okay. Are you good with all this, friends? Are you good with all this? This is idea about what? Idea about. So this is, sorry, Krishna, you are saying something.
Yeah, we are.
Somebody is saying something. I don't know who is speaking. Okay, it should be some.
We are good. We are good.
Is this clear to all of you? Is that good for everyone? Any questions or anything on this? No, right? You are perfectly fine with all this. Okay, no problem. And the upcoming sessions will be much more interesting because we apply all that there. The string topic, that will be very interesting. More than strings, data structures will be much more interesting. Okay, and that they are the core concepts of programming. They are heart of any development. Okay, so that's all for today, friends. We'll stop here. We'll connect back tomorrow. Okay, so I think I shared this program as well. Okay, friends. Okay, we'll stop here. Thank you, friends. Good night to everyone. I'm just stopping recording.